Welcome back. In this video, we're going to learn about the differences between distance and displacement and average speed and average velocity. To do this, we're going to use a problem called sailing. The ship sails 50 miles north in 1 hour, then 20 miles south in 0.5 hours. A. What is the distance traveled? B. What is the displacement? C. What is the average speed? And D. What is the average velocity? Our first step to solve this problem is to write down the given information. So here I've written down what they've given us. The first distance is 50 miles north. Second distance is 20 miles south. First time is 1 hour, and the second time is half an hour. I've labeled them D1, D2, T1, T2, so that the first time corresponds to the first distance. Our next step is to start drawing it. Since we're using vectors, the drawing will help us to add and subtract it based on what we need. Our first vector is 50 miles north. We draw this with an arrow. Since we can't draw north, we just draw an arrow going up. Our second vector starts where the other one ended and goes down for south. And this is 20 miles south. Notice I also put the time there. Another thing to note is that the 50-mile north arrow is longer than the 20-mile south arrow. This is to represent the different lengths of them. Now, if you remember from our previous video, the difference between a vector and a scalar has a direction. A scalar does not. So 50 miles north has a direction, north. That means it's a displacement. Time does not have a direction. It's a scalar. So 1 hour does not have a direction. So, as I said, displacement has a direction. So I'm going to represent the total displacement from the very start of the 50 miles to the end of the south miles. Now that everything's drawn, I can begin to actually answer the questions. Part A asks us to answer what the distance traveled was. Simply add the two distances because their direction does not matter. So distance equals 50 plus 20, which is 70 miles. Not chickens, do not give me no units. Part B asks me for displacement. Displacement's different, it's a direction. So now I actually have to include the direction. The difference between the 50 north and the 20 south is one's going up or north and the other's going south or down. To represent this mathematically, we use plus and minus. So our displacement is positive 50 minus 20, which gives us positive 30 miles north. The positive and the north both mean the same thing in this case. Part C asks us to find the average speed. Average speed is found by doing the total distance traveled from the start to the very end divided by the total time that it took to make the trip. So if you went across the country and it took you 3,000 miles to get there, but you stopped 3 times on the way, stopped for an hour or 2 on the way, your average speed would be very long compared to what speed you were actually traveling on the road. Here our average speed is a little bit easier to find. So speed is the distance that you just found divided by the total time of the trip, which I'm going to represent as a t. Notice I put a little hook on the t. This is so that later on when we have equations with t in them, just like from the previous video for the graphing, you can tell the difference between the t and the plus. So our distance was 70. Divide that by 1.5. 1.5 is because 1 hour plus 0.5 hours equals 1.5 hours. Woo! Yay, we can do math. So 70 divided by 1.5 gives us 46.7 miles per hour. Not chickens. Now for the last part of the problem. It asks us to find the average velocity. Notice that distance and displacement were different. Distance used the total distance, so everything just added together regardless of direction, and displacement used the direction. So up or right is positive, down or left is negative. You add those together and you get your displacement, and then you include the direction along with the units. Here with velocity, we also include direction with units, except now we're using displacement over time, not distance over time. So our velocity, v, equals 20, which is our displacement, over 1.5, which is our total time. Sorry, not 20. 30. I misread. 30 divided by 1.5 gives us 20 miles per hour. Now here I left it as 20 miles per hour because we're only going up or down. If you want to leave it just as a positive 20 miles per hour, that includes the direction. If it came out negative, that would also include the direction if it was going down or left. So positive means up or right, negative means left or down. You could also do 20 miles per hour and then say north to make it more clear. So that's all for this problem. Make sure to come to class with any questions you might have so I can clear it up. See you there.